Hey, Algebra 1. We're going to talk about 8-5 using the distributive property, particularly in factoring. Why factoring? Because when we factor, we can solve. Factoring allows us to simplify some complicated fractions. Factoring allows us to solve some radical equations. There are a lot of things that you'll use in later mathematics that involve factoring. And one method is using the distributive property. Now, you may remember from past courses, well, the distributive property was so that I could get rid of parentheses, right? So that would give me 3x plus 12. But the distributive property works both ways. Not only can I distribute something through parentheses, but I can pull something out. And that's why we learned about greatest common factor. If I look at 9x and 18, you might say, oh, they're both divisible by 9 because 9 is the greatest common factor. Well, that's what I want to pull out. I want to pull out that GCF of 9. Well, when I divide that out, I'm going to have an x left here, and I'm going to have a 2 left here. Okay? So that, and think about it, it checks. If I distributed it back through, I'd get 9x plus 18. Okay? And then it gets a little bit more complicated. Okay? 27y squared plus 18y. Well, yeah, they both have a common factor of 9, and they have a common factor of y. So on this one, I want to pull out a common factor of 9y. That's what I want to pull out. And when I pull that out, what do I have left? Well, I'm going to have a 3y left here, because 9y times 3y is 27y squared. And I'm going to have a 2 left here. 9y times 2 is 18y. So this is factored form. I've factored using the greatest common factor and the distributive property. I have undistributed that 9y. Okay? You might look at this one. This is guided practice 1A. And what it has is it has a common factor of 3. So that's what I want to pull out. I want to pull out that 3. I don't have any variables in common, so they'll stay the same. 3 goes into 15 5 times, and I'll still have a W. 3 goes into 3v, v times, and there I have undistributed or divided out that common factor of 3. Now, part 2 talks about factoring by grouping, because sometimes you have a large number of factors. In fact, if I have 4, I really want to look at them in pairs, okay? And I look at these, and they have they have an r in common, and they have a factor of 4. So I want to pull out that 4r. Now, when I take it out here, I'm going to just have a q left, and when I take it out here, I'm just going to have a 2 left, okay? And then I look at the second part. Well, they have a common factor of 3. And that's going to leave me with a q plus 2. Okay? Now, when I look at what I have, and I call this a chunk, just so you know, I've got 4r times the quantity q plus 2, and I've got 3 times the quantity q plus 2. And that's kind of like saying, well, I've got 3x plus 5x, and don't I add that and say, well, 3 plus 5 is 8, so this is equal to 8x, because that greatest common factor comes out, so I can add 3 plus 5. This chunk is like that x. So I'm going to pull it out because it's my new greatest common factor. And what am I going to have left? 4r plus 3. Because when you think about it, though you can do this in your head, the math, the technical math, says you're doing 3 plus 5 times x. You're pulling out that factor of x and adding what's left. Okay? So we're doing that same kind of thing. I've got this chunk. The chunk's always got to be the same. Okay? And you might look at that and you say, well, what if we change the order? So what if we did? Let's try it. Let's say maybe I wanted to put the q's together. 4qr plus 3q plus 8r plus 6. Okay, so if I look at these two and I look at these two, these just have a GCF of q, and that gives me 4r plus 3. These have a GCF of 2, and I'm left with a 4r plus 3. These are still the same. I can still pull them out. And what's left goes into my other binomial. Okay? Now, the nice thing about these is I can check with FOIL. Look, 4r times q is 4qr. Oops, 4qr. Q times 3 is plus 3q. 2 times 4r is plus 8r. 2 times 3 is 6. And I am back to exactly what I started with. Notice my factors are the same, just in a different place. So I can change the order. It's kind of like the prime factorization of a number is unique. So this is like the prime factorization of this polynomial. Okay? All right, let's try another one. Guided practice 2a says I've got Rn plus 5n minus r minus 5. So I want to look at these two together, look at these two together, and yeah, if you change the order, that's fine. Just make sure you keep your minuses with what they go with. Okay, but I just kind of leave them by how they are. Okay, so Rn and 5n, they have a common factor of n, so I'm going to divide that out, and that leaves me with r plus 5. And that really does mean that I need an r plus 5 over here, because that needs to be my new GCF. Well, they're both negative, so I'm going to pull out a -1. Okay? This is my new GCF, so I'm going to divide it out. What's left? N minus 1. Does it check? There's my r plus Rn. Here's my 5n. Here's my minus r. Here's my minus 5. I got right back where I started from. Okay? I'm hoping this is helping make a little more sense. All right. Guided practice 2b. 3np plus 15p minus 4n minus 20. Okay, so I'm going to put them in pairs. That minus is stuck with the 4. Okay. 3 and a p, so I can pull out a 3p. That leaves me with an n plus 5. Over here I need an n plus 5, but if I look at this, my greatest common factor is -4, and yeah, that's going to leave me with an n plus 5. Okay, this is my new GCF. What's left? Does it check? 3pn or 3np. 15p minus 4n minus 20. Okay, so I can check that with FOIL. Now, the only difference in example 3 is the order. It's kind of got a weird order. Okay, And I wouldn't have done it in the order that they did it in. Okay? They've got 2mk minus 12m plus 42 minus 7k. So if I'm looking at this, see, I'm going to take out 2m and the k's first. Well, here the k isn't going to be first. So this is where I would probably switch these around. Because, you know, if you think of this as plus negative 7k, you know, commutative property works. Okay, but I'm going to just keep it as minus 7k plus 42 because I want the k's to be in the same position. Okay, so when I put these two together and I said I'm going to take out a 2m, that gives me k minus 6. All right, that means over here I need a k minus 6. Well, that means I got to divide out a negative 7. Yep, because that gives me a negative 6 over here. Here's my new GCF. What's left? 2m minus 7. If I check, there's 2mk minus 12m minus 7k plus 42. It checks. All right, let's try another one. Ooh, do I have enough room? No. I'll do it up here. Okay, so guided practice 3A says C minus 2CD plus 8D minus 4. Now, you might look at this and say, hey, Susan, can I change it so that the D's are together? Sure. Yeah. Or you might say, okay, I kind of like this because the C's are together. Does it matter? Not really. Okay. You might say, well, this has a D first. Could I put the D first? Sure. Okay. So you could do it all kinds of different ways, but I kind of want to have that D in the same position. Okay. Well, I like to change the second one, so I'm going to switch this one around. But it doesn't matter. I could change either one. C minus 2CD minus 4 plus 8D. See, now my D is second in both pairs. Okay, I want to pull out a C. Well, C goes into C once, minus, I'm going to have a 2 and a D left. So over here, I need to have a 1 minus 2D. That means I need to pull out a negative 4. Okay. 1 minus 2D is my new GCF. C minus 4. Okay. Does it check? There's my C. Minus 2CD. Minus 4. Plus 8D. Back to where I started. Okay. So that's kind of nice. Probably better look at 3B because it's got a second power in it. Ooh. Okay. 3P minus 2P squared minus 18P plus 27. Okay. Well, you know, this isn't really kind of standard form because standard form would put this first. So I'm going to switch these two around. I am not going to simplify because you don't know how to do those yet. Okay? And this is particularly like what you'll do in 8-7 because they'll take a trinomial and they'll say, break apart that middle term so that you have 4 terms and factor by grouping. So we're just going to leave it as 4 terms because we know how to do that. All right, I've got a P in common. That's all I can take out. That gives me negative 2, and I'm going to still have 1p left, plus 3. I need a negative 2p plus 3 over here, which means I need to pull out a 9. And it's a plus 9, because this would be like plus a negative, so I'm always going to have that plus there. This is my new GCF. And what do I have left? P plus 9. Now, does it check? Negative 2p squared plus 3p minus 18p plus 27. Right back where I started from. Okay, the next part I think you probably are good on if you can get this. Okay, solving just says, hey, if it equals 0, set each factor equal to 0 and solve little equations. Okay, talk to you later. Bye.